Cool. Now, if you've mastered the 45, 45, 90 triangle, you are ready for the 30, 60, 90, which also has special relationships with their sides. Now, even though there might be more out there in existence, these are the two that pretty much the whole world studies. These are some good, they're good little ratios. They're good little relationships with the sides. So sort of like I did before, I've got a 30, 60, 90. These always have sort of a shorter side, and then you've got like the long leg, and then you've got the hypotenuse, of course, which is the longest of all. So the relationship here is we're going to call the short side S. So, you know, that could be any side length right there. And the cool relationship here is that the hypotenuse is always twice as long as S. Okay, so you double whatever number's here to get the side across. And if you want to know the long leg, it's another funky radical one. It's going to be the side times the square root of 3. So to do just sort of like a basic example so you can see what this is going to look like is it might be something like here's the 30. I need to make this a little bit shorter because that was terrible. Okay, see? Yeah, that's still terrible. But anyways, that would be 30, that would be 60, that would be 90. And so if you saw a triangle like this and somebody said, hey, that's the 7, what you would do is sort of look up here and compare, okay? You can rotate the picture if you want to. I usually look for stuff that's across. Like, in other words, the 7 is across from the 30. So I know that it's going to relate to whatever's across from the 30 in this picture. So I'm looking at my short side right now. So the short side S is a 7. And so if I know that that's a 7, I can just label everything else. I usually go to the hypotenuse next because it's just easier for me. But if the short side is 7, then the hypotenuse is 2 times 7, which is, of course, 14. So that length is 7. This length is 7. And if I want to get my long leg, I just multiply the short side by the square root of 3. And I don't type anything in the calculator. Once again, I don't have to do Pythagorean theorem. I don't have to do SOHCAHTOA. You just know these relationships and you will get exact, pretty answers with not a lot of math. So let's do another one. Okay, so for my next one, I'm just going to erase so that I can use my same awesome picture from here. Okay, so maybe now for this one, you see a picture that is labeled 30, 60, 90, and maybe this time they're going to give us the hypotenuse. So what I like to do is, you know, look at the picture and compare from here to here. So sort of like I did on 45, 45, 90s, they've given me the hypotenuse of this picture. So when I look up here, I'm going to compare it to the hypotenuse of that picture. So when I go to set up an equation, 2s has to equal 10. Those are in the same spot, so I set them equal. Now, how do I find s? Well, do it in your head or do it on paper, but either way you're going to get s is 5. So s is the short side, so I'm going to move that and let's see where, you know, some people just have a hard time, like where does the 5 go? Like, is the 5 here? Is the 5 here? Like, what are we going to do? Well, the 5 is on the bottom, and the reason I know that is because that is the one across from the 30, and in this picture s is across from the 30. So if I want to now jump over to my long leg, I just take that 5 and multiply by the square root of 3. So just a lot of matching. Let me do one more of a funky one. So, funky one. I'll turn the, oh, Lord Almighty. Let's try to fix that. Okay, so let's turn this triangle around. All right, so this time maybe somebody tells you like that's a 12. Okay, so this one is going to be kind of tricky. So when I look at this picture, I'm going to highlight once again. Okay, and I shouldn't have highlighted that thing before. Okay. Oh, I've destroyed my stuff. Okay, that's the original. This is the new one. Okay, so in this one, the 12, I'm going to highlight. Now let's look at where it is, guys. Okay, it's across from the 60. So if I want to compare it to something, I need to go to the one that's across from the 60 here. That's the one I'm going to highlight in the same color preferably, but I didn't, so whatever. Okay, these two that are highlighted in not the same color, but I wanted them to be, those are going to be comparable to each other. So that's going to be the equation. So I'm going to do 12 is equal to s root 3. Now, I'm trying to find s, guys, so I need to get that number off of s, which means I need to divide that number away. So I'm going to divide it. Now, when you do this, remember what I said before, 12 root 3 is s, okay, technically. But if you want the pretty answer, you need to rationalize. So I don't like the radical on bottom, so I multiply by root 3 over root 3. And then I do 12 root 3 over, that's going to turn into a 3. Now this is still not done because 12 over 3 can reduce, right? What is 12 divided by 3? Well, it's 4. And this is your final pretty answer for s. Now where does s go? Is it going short leg or is it going hypotenuse? Well, if you look up on the picture, the s is the short leg. It's across from the 30. So I'm going to put the s right here, 4 root 3. And now I need to take this and use it to get to my hypotenuse, right? Now, the hypotenuse is 2 of these s's, so I need to double this. So how do you double something like this? Well, it's easier than you think. You actually just double the number on the outside, so it's 8 root 3. And that is it. Woo! Lots of fun, right? Pay attention. Do the highlighting, set up the equation. The only people that usually get these wrong are people that try to do it all in their head because they think they're awesome and then they make a derpy mistake. So show your work, guys, and you will get it right, 90% of the time. Thanks.